Hey, welcome. Today we're going to tackle something that sounds a bit scary at first, but is actually super powerful, the language of economics. You see, at its heart, economics isn't just about spreadsheets and money. It's really about relationships, how one thing impacts another. And the absolute best way to see those relationships is to tell a story with a simple graph. So, let's jump right in. Just think about it for a second. If you suddenly got a nice raise at work, would you spend more? Yeah, of course you would. It's almost instinct. Well, that simple, totally intuitive connection, that right there is what economics is all about. It's just a story of cause and effect. And to tell these stories right, economists use a specific set of tools. So today, we're going to dive into our source material here and learn that basic language, the grammar you could call it, so that the next time you see a graph on the news or in an article, you won't just see a line. You'll be able to read the story it's telling.
All right, so the first building block of this whole thing is the most important one. Before we can even think about drawing a picture, we need a rule, a simple rule that defines the relationship we're talking about. And in the world of economics, this rule has a name. It's called a function.
Okay, I know, that definition looks super technical, right? But don't let the fancy words fool you. All this is really saying is that one thing, we'll call it y, depends on another thing, we'll call it x. That's it. For any given x you pick, you know exactly what y is going to be. It's a clear, predictable rule, no guesswork. And you know economists, they love a good shorthand. This little equation you see here, y equals f of x, is just a quick way of writing y is a function of x. It's a universal code that just means the value of y depends entirely on the value of x. Simple as that. So the two parts you really got to get are these. The independent variable, x, is the cause. It's the thing you can change, or the thing that changes first. The dependent variable, y, is the effect. Its value depends on whatever x happens to be. So in our first question, your income is x, the independent variable, and your spending is y, the dependent one. All right, so we've got our rule, our function. But let's be honest, an equation on a page can feel a little meh, abstract. The real magic, the part where it all clicks, is when we turn that rule into a picture, a visual story that our brains can understand in a split second. So let's make this real with a simple example from our source material. Picture a garment factory. The relationship we want to look at is between how many workers they have and how many shirts they make. And the rule is super simple. For every one worker you hire, the factory produces 3 shirts per day. And you can see how that simple sentence turns right into our function notation. The output of shirts, O, is equal to 3 times the number of workers, N. See? O is our dependent variable, because the number of shirts you get depends on how many workers you have, which is our independent variable, N.
Okay, now for the fun part. Let's actually see this rule in action on a graph. We always put the cause, the number of workers, on the bottom axis, the horizontal one, and we put the effect, the number of shirts, on the side axis, the vertical one. So if we have 1 worker, we get 3 shirts. Boom, that's point A. If we have 2 workers, we get 6 shirts. That's point B. You connect those dots, and suddenly you have a line that tells the whole story perfectly.
And when that relationship is super consistent like this, every new worker adds the exact same number of shirts, the graph is a perfectly straight line. We call this a linear function. And trust me, you see these all over the place in economics because they just make relationships crystal clear.
Now, these straight line stories basically come in 2 flavors. Sometimes, like our income and spending example, as one thing goes up, the other thing goes up too. That line climbs up and to the right. But other times, think about gas prices and how much you drive. As one thing goes up, the other goes down. That line slopes down and to the right.
So this breaks down into 2 really simple types of stories. A positive relationship is when both things move in the same direction, and its line always slopes up. A negative or inverse relationship is when they move in opposite directions, and its line always slopes down. Just by glancing at the direction of the line, you instantly know the kind of story you're looking at.
But just knowing the direction, up or down, isn't the whole story. Is the relationship a really powerful one, or is it kind of weak? To figure that out, we need one more tool. We need a way to measure just how steep that line is. And that, my friends, is called the slope.
This is the million-dollar question, right? Is the line a gentle little hill or a steep cliff? And what does that steepness even tell us? Well, the slope of that line isn't just some random detail. It's actually the most important part of the story. It tells us the exact rate of change, precisely how much y changes whenever x takes one single step forward.
So, how do we actually find it? It's way easier than it sounds. The secret is the slope, and its formula is just the change on the vertical axis, what we call the rise, divided by the change on the horizontal axis, what we call the run. You probably heard rise over run back in math class, and honestly, that's all it is. You know, this quote from our source really just nails it. Let's just pause on it for a second. The slope isn't just a number. It is the precise measure of how much our effect, y, changes for every single 1 unit change in our cause, x. It's the engine of the relationship.
Okay, let's put this to the test with our factory example. First, you pick any 2 points on the line. It doesn't matter which ones. Let's use point B, which is 2 workers and 6 shirts, and point D, which is 3 workers and 9 shirts. Now the vertical change, the rise, is 9 shirts minus 6 shirts, which equals 3. The horizontal change, the run, is 3 workers minus 2 workers, which equals 1. Last step, just divide the rise by the run. 3 divided by 1.
And the answer is 3.
And that number, 3, it's everything. It brings us right back to our original rule. The slope is telling us the core truth of this story. For every 1 additional worker you hire, the factory produces exactly 3 more shirts. The slope isn't just part of the story, the slope is the story.
So there you have it. You've got the tools now, a function to make the rule, a graph to see the picture, and the slope to tell you the precise story. So start looking around. What about the hours you study versus your test scores? Or the price of coffee and how many cups you buy a week? They are all stories just waiting for you to put them on a graph.